This is Algebra 2 with Trig, 1C.0. We're going to graph and write equations of circles. What we're talking about today was covered in your geometry class, but we'll pick it up here also for sure. A circle is a set of all points in a plane that are equidistant from a fixed point. That fixed point is called the center of the circle. The distance r between the center and any point on the circle is called the radius. Now, when we do our calculation from our center to the edge of the circle, that is actually the distance formula. x2 minus x1 and y2 minus y1. Quantities are squared. You have your distance, which we're calling a radius. You would have to square both sides, and you no longer have the square root. So you have the radius squared. That is the equation of our circle. Because it's x minus 0, we just call it x. X is squared, and y minus 0 is y, so y is squared, and r squared. That's going to be if your center is at the origin. You'll have x squared plus y squared if the center is at the origin. If the center is not at the origin, or you're trying to determine your center, the center horizontal distance is your h, x minus h squared. You know what h means. You've worked with that in the past. Plus y minus k squared. You've worked with k before. So it means the same thing. It's your vertical distance. And following our formula here, r squared, we take our radius squared as the value in your equation. It's almost like a squared plus b squared equals c squared. It's all the same formula. So if we come down here to calculate and determine our graph, what seems funny about our equations? Bless you. What seems funny about this equation? There's an x and a y for sure, but when we come up and look at our equation, we see that there's an x and a y. We want the x squared, we want the y squared, but we want them on the same side of the equal sign. So I'm going to add my y squared over to the left side. I'm going to add my 4 to the other side. So I get x squared plus y squared equals 4. So there's my equation. You could call that in standard form. What can we tell from an equation? You should be able to tell what the radius is. You should be able to tell what the center is. So what's our radius? The radius squared is the value on the outside of the equal sign. So r squared equals 4. So r is going to be plus or minus 2. We're not going to consider negative 2. We're only going to consider positive 2. So the radius is 2. And our center is the value inside the parentheses. We don't have parentheses, just x minus 0 and y minus 0. So we don't have those, so our center is at 0, 0. So we find our center, 0, 0, and we do our radius of 2, count 2 up, 2 left, 2 down, 2 right. And you make your circle. Try to make your curve on your circle to be as wide as you can, and you'll make your circle look better. The common mistakes in drawing circles is you cut too short and come across. Make it flat on one side. What do we notice is going on with example 2? We have an h and a k. What is our h value? If it says x plus 2, it tells us that the h value is negative 2. What is our k value? Positive 1. So that is our h and our k. That is our center. So it's easy to find the center. It's the opposite of what's inside with the x, and it's the opposite of what's inside with the y. What's our radius? We know the outside of the equal sign is r squared. So you take the square root of both sides, and r is going to be 3. We don't consider the plus or minus because the radius isn't going to be negative, so it's going to be a positive value. So we're going to go to our center of negative 2, 1, and do a radius of 3. And there we got our circle. You can graph the circle. What's different down here? Here we have 2 equations because we are going to graph the system of equations. And you probably have an S on the end of that. System of equations. Now what's funny about, or what shapes do we have? What shape is the first equation? What shape is the second equation? You need to have an idea of what you're working with. You can't do it if you don't know what shape it is. What shape might the first one be? Maybe a circle, but what's the question mark? What's weird about it? It has values in front of the x squared. Right? It has a 3 and has a 3 in front of the y squared. That's not part of our standard form. We don't have an a value in front of our coefficient. So we're going to have to divide, or we'll just call it multiply by 1/3, and that will take that 3 away. It's not that it can't have a value in front. It's just so we understand what all the values are and what the radius is, we need to be sure that the coefficients for x squared and y squared are both 1. So we can divide those away. They would both have to be the same. They can't be different numbers. So if this was 3x squared and this was 9x squared, we couldn't do that. It wouldn't be a circle. It would end up being an ellipse, an oval. One direction would be longer than the other. So we want to be sure we know what we're looking at. They have to be able to be reduced so the coefficients are 1. Now I see that my center is at 0, 0, and my radius is 3. So I get my circle. Now, what about this other equation? What shape is that? What do you notice when you look at it? Is it a circle? Doesn't have x squared, y squared. Not a circle. Is it a parabola? Parabola requires x squared, so this doesn't have x squared. So nope. What's the other option? It's a line. It's a linear. It is linear. So this is in the format of y equals mx plus b. So that means you start at your b value and you do a slope of 1, up 1 over 1. And you plot the dots up to the right and then down 1, backwards 1. You continue in that same pattern. There would be your two graphs and where they intersect. They're intersecting at 0, 3, and they're intersecting at negative 3, 0. So what we notice about this one, this is not a circle. This is only x squared. It's not y squared. So this is a parabola. So you got to think about how to graph a parabola. You could find the line of symmetry, negative b over 2a, plug it back in. You could also take what you have, set it equal to 0, factor it. Set those factors equal to 0 and find out that it touches the x-axis at exactly one spot. If it only touches at exactly one spot, then that has to be the vertex. And the rest of the factoring, or the rest of the graphing is easy. It's just the parent function. 1 over 1 up, 2 over 4 up, and reflect that across. So we graphed our quadratic. Now we look at our other equation, and we see that this is linear again. In this case, it's having us at the y-intercept of 3 again with a slope of 1. And our intersections are going to be negative 2, 1 and negative 3, 0. That's where the two graphs cross. On our flip side, it talks about writing an equation in standard form of this circle. What do you see? What do you need to know to write an equation of a circle? What you need to know, number 1, determine the center. Number 2, figure out the radius. Those are the two things you need to know. Because your equation of a circle is right there. So if my R value is 4 and my H and K, because that's my center, my H and K are 0. A lot of people ask, do I need to write everything down? Just more mistakes happen if you skip steps. But granted, these are pretty simple ones. X minus nothing squared is x squared. Y minus nothing squared is y squared. And 4 squared is 16. There's your equation. Letter B is a little trickier to be skipping steps. Go ahead, pause the video, give it a try, and I'll walk you through it. So, as you noticed, you had your R value. That's your radius. This is your H and your K. So if you're thinking about your equation, you can't write an equation if you don't know what the equation is supposed to look like. So I would suggest to start with what the equation is supposed to look like. Then you can plug in your values that you know about. Now, how do we go about squaring 2 root 6? 2 root 6 times 2 root 6. When you square 2 root 6, we have 2 squared, and we have the square root of 6 squared. Square root of 6, when you square a square root, you get what's inside. Or root 6 times root 6 is root 36, and the square root of 36 is 6. However you want to think about it. X squared plus y minus, or actually plus 9 squared equals 24. And that would be your circle. Now, if we were going to graph this, what would our radius be? If we were to graph this, you would think about right and left nothing. You'd go down 9, and what would you do to figure out your radius? Square root of 24. Well, you could use a calculator to figure out the square root of 24, but that's not necessary. What is the square root of 24 close to? You want to use perfect squares. That's what you're familiar with. So we have 1 squared, or 4 squared, or 9 squared, 16 squared, 25 squared, 36 squared. So this is very close to 25 squared. Not 25 squared, but the square root of 25, otherwise known as 5 squared. So this one is really close to 5 times 5. You agree with that? So this is close to 5. So our radius, I would count up 5 and a little bit less if I was making my graph. A little bit less than 5. Definitely a lot more than 4. But it is less than 5. Because 4 would require a 16 to be there. This is way bigger than 16. But this is less than 25. Square root of 25 is 5. So this is less than 5. Okay, last one. What's different about this question? This one has a point. -4, 7, and we graph it. Our center is at the origin. What don't we know? We don't know that the value of the radius. We know the center is at the origin, but we don't know what the radius is. So thinking about my equation again, I know this point is going to be considered my x and the y. So I have -4 minus 0 squared, and 7 minus 0 squared equals r squared. I don't know what my radius is. So that 16 plus 49 is my radius squared. So that is 65 is my radius squared. I don't need to know what my radius is. I need to know what radius squared is. So I'm in the right spot now. So my equation is x squared plus y squared equals 65.